Do you know how many promises are created every time you use the async await keyword? Did you know that a poor error handling can lead to memory leaks? How about visualizing how many objects JavaScript is allocating? Did you know that you can collect data from a Node.js process and plot it into a visualization tool? Hello my friend, how have you been? Erick Wendel here, and today I brought something special for this video. I'll go through the 5 most important tips for JavaScript promises that I found in a conference talk given by Snell, one of the most important Node.js collaborators ever. His talk is about broken promises. He brought examples from the real world and he teaches us what people shouldn't do while using JavaScript promises. I watched his talk and I strongly recommend you watching this after this video. If you do, comment there that you came from Erick Wendel's channel so we can make some noise there, right? I won't repeat what he said there, but I will complement by adding some thoughts, and as you are used to seeing here in this channel, I'll code a lot of examples so you can understand them in practice. Are you excited? Let's begin! Back in 2020, during pandemic, I gave a talk about deep dive into Node.js strings. During the questions and answers session, some guy asked me, "Hey Eric, how could you relate strings to what Snell speaks in his Broken Promises talk?" Well, this was very generic question, and I honestly didn't get what this guy wanted from me. But after the session, I was like, oh, that talk where James says about error handling and best practices for promises. This talk was insightful, and I wish every JS developer would watch it someday to avoid making mistakes with JavaScript promises. In summary, James speaks about real-world experiences working as a software consultant, where companies reach him to find some performance issues and how to solve them. As I usually say, most of the problems in software are not technology problems, but the one who's between the chair and the table. People do mistakes, and those mistakes reflect directly on how healthy is a software application. I was browsing here on YouTube and I found out the Node.js channel. If you haven't watched a single video from there, you don't know what you're missing. There, you'll find a lot of interesting subjects to study about Node.js, and also find some talks I've given during the big Node.js events that happens around the world. YouTube recommended me the Snell's Broken Promises talk, and I had an idea. Why not watch it again and record something about it, showing practical examples and adding some compliments. I actually picked some specific video talks in the Node.js channel, and they are already in my video backlog. Let me know what you found about this content so I can record about others as well. Here we are, Broken Promises, a very insightful talk, and I think you're gonna love it.
Right? So what we have found in the overwhelming majority of cases, when anybody is using promises, they are, at some way, at some level, using them incorrectly. So that is the inspiration of this talk, is basically all the ways that we have seen customers using promises incorrectly, and kind of breaking down why it's incorrect.
As I said, I won't actually repeat the whole talk. You should watch it by yourself later. I gathered the top most interesting subjects I found in this video, and now I'll dive into them. Before moving on, please don't forget to press the like button. It helps a lot with the work I've been doing in this channel. And this week I released the first season of my Mastering Node.js Streams training, where I teach you all my secrets to using the most powerful Node.js feature to process big loads of data, the key to process terabytes of data using JavaScript, and much more. The link is already in the video description. You can also suggest what you want to learn by commenting here in this video. I usually read all comments one by one and I add them to my content backlog. Every week I publish a new video here in Portuguese or in English about JavaScript, career, and many tips to help you to conquer that dream job and make you a dev specialist in JavaScript. If you are not subscribed yet, subscribe to this channel so you won't gonna miss all the content I'll be publishing here. For my examples, I'll be using Node.js V18. Make sure you have the same version as me so you won't have any environmental problems. If you haven't watched my video about recreating Node.js from scratch using V8 and libuv, I suggest you put it into your watch list in case you want to deep dive into how Node.js works behind the scenes. There, I create custom C++ functions and invoke callbacks. You'll find interesting how promises are executed in JavaScript. They are just a notification system to help us handle callbacks, and you could have millions of them just finding memory, as long as you had enough memory to hold those JavaScript objects. And that leads to the first tip James tells us.
So promises are powerful. Yes, they're in a language. You really have to understand how they function and what their purpose is, right? When to use them, and especially when not to use them, right?
I'd go further. We, JavaScript developers, should understand how the JavaScript lifecycle works, how the event loop works. This information you also find in the video where I recreated Node.js. Take a look at later. The best way to understand what is misbehaving on our application is to monitor it. Node.js lets us collect tracing data, and we can use a tool to visualize what happened during an execution. The tool we're gonna use is the same James shows us in his talk, the Chrome tracing. All right, so here, as I talk to you, I'm using Node.js 18, all right? So you should use the same version as me. And I installed the Google Chrome. And you should use the Google Chrome as well. And you can see the Chrome tracing here, all right? On this URL. Nice. We don't know anything here. So just keep the application open for now, and let's write our code. The first thing James was doing in his talk was showing how this tool is working, right? So we're gonna try reproducing, but I show a different example for you, okay? So let's create a file. I'll call it tracing events to show how we can collect data from a Node.js process, all right? The same idea he was showing there. So counter 0, and I will do something a bit different. As his talk is a bit late, like 2019, the tracing here was a bit different. For now on, we need to kill the process to see the file and to see the metrics running on. So we're gonna do it manually, all right? So I'm gonna create a counter and some timers, and when it reached some point, we kill the process and we can see the tracing file, all right? Let's do in practice. So I will have the set interval, and I will simulate some action that will actually block the Node.js event loop. So I will actually create an index less than 1, like 1 with 9 zeros, right? So we can have some heavy operation. And then I will say if our counter reaches 10, less than equal, we're gonna kill this process, all right? And then we can run a test. Just it for now, okay? So we can run this project for both ways. We can have node trace events enable, all right? And the name of the file, so the name of the file here is trace events.js, or we can run as James was doing there. We can use specific categories to actually get some metrics from what we need from Node. But natively, if you run the first command, it will get the v8 node and node.async hooks, all right? And we use the same name of the file. So default, we get this information. Async hooks gives us information from all the process, all the timers, all async operations. Node, we get information from the runtime, environment, and V8, what is being executed behind the scenes by the JavaScript, all right? Nice. So I'm gonna copy and paste it here, all right? Oops. Oh, see that we have actually already our trace file, but I'm gonna remove it because it's an error. And what is missing here? Let's try running again. I++, oh, it's index, right? Nice. So remove it again. Trace log. All right, our application is being running, and after all, we're gonna see our trace file. Okay, now we can see that this trace file is a big file that actually replicates and shows us what happened during this execution for our program. So we can go back to our Chrome browser, go to the tracing, and upload this file. So I'm gonna grab our tracing file, and we can see some things here. But first of all, you can check out all the navigation shortcuts right here. So I'm gonna use W to zoom in, S to zoom out, A to go to left, D to, and so on, okay? Perfect. So here we can see every tick, every time our callback, every time this piece of code was being executed, okay? So we can see here, I will actually show all of our code running. And you can see we have a timer, and you can see all this red piece of code here. This red piece shows us whether the JavaScript code was executing. And those spaces that we see here is the event loop going on like a while true, and behind the scenes managing async tests or doing some background work, all right? But every time you see these pink boxes here, you can relate to V8 executing, okay? So if I click there, you can get more informations about what happened during these timers, how long it took to be executed. So every tick we have here, it's almost a second, right? So we have here, actually not a second, it's half a second, right? Start, end, and so on. If you click on the callback, we can see more information here, promises, and so on. Something cool about this tool is that we can actually see what Node.js was doing behind the scenes, right? So let me go here. I can actually select it and see what was going on. So he has been running some optimization code, some exiting. We can see here all the information about how the project was working. So we can go and look through like how many promises were running. So we have just one because we have top level await in JavaScript, right? So every time we run our program, we have at least one promise behind the scenes working, okay? Nice. We have how many times the timeout callback was running, the tick object, and so on. Okay, let's try checking what if we just comment our for loop from here and run again our trace. But now I will actually comment it with for, because when we run this command again, we can see another log file and we can compare it. Now I'm gonna run the first one, which is gonna get something very similar. Trace events enabled, I think. Now it got so faster, right? So I'll just copy here because I miss, no, it's just missing a D, right? Perfect. Let's go back to the Chrome browser and I'll grab the one, right? We just generated, so we can see the difference. So now you can see how spaced is each iteration, right? This means that the Node.js was executing something for a while. You can see how long it took, right? 0 milliseconds to 15, maybe 18 milliseconds, and where our timers were running. So we see that our timers took like a lot less, right? 3 milliseconds to execute now, and we have a safer environment, right? And we can see the tick object and how long our event loop was in idle, waiting for more requests, and so on, okay? This is just an overview for this tool because we're gonna use a lot this tool later, okay? Going back to the talk, James shows us what happens in those pink boxes. Notice that his Google trace is a bit different, but it's the same idea we just ran in our examples.
These pink boxes right here are the times when Node and V8 are actually executing JavaScript. The blank spaces between are times when no JavaScript is being run. That is times when the Node event loop is doing other things. In this case, it's waiting for that event, for that timer to fire. Right? So within that time, the event loop is actually spinning, right? But while the pink boxes are executing, the event loop is not spinning. The event loop is completely blocked.
As he said, when the event loop is blocked, any concurrent user that might want access to our application would face timeout issues. James says that the pink boxes are where our JavaScript is being executed. The spaces mean async operations and other tasks event loop is executing in the background. Promises are objects that are meant to be created and executed in the future. Async tasks, right? If we create a promise and the promise is finished in the same pink block, it means this promise is actually a synchronous operation. What? A promise would execute sync operations? A good example where promises are synchronous is this code. Transforming a function result by adding the async keyword doesn't make it asynchronous. Asynchronous operations are functions that you can have the result right now. You have to schedule the execution, and when the operating system is ready, it will respond back. Like when you are reading a file or inserting data into a database, you have to wait until a connection is established, you get a confirmation, and then you continue from where you've stopped. From now on, I won't actually follow the same order James did in the video. I'll start with the most frequent mistake I still have seen my students committing. Alright, to see the most common mistake I've seen, let's create a file. Alright, so promise object.js. Okay, James now was talking about this and I've seen this a lot. Let's go through it. Some people try creating a promise object, all right, and they put async here, resolve, and reject. Okay, so if we try running this code, it will actually run, right? Resolve, okay. So const p, actually I could put here .then result console.log result. Okay, if we run this code, what happens? Well, we can see that everything is working fine, right? However, as we can see async here, we could think that we can await for async functions, right? So what if we try using promise.reject? So we are trying to consume a function that just rejected, right? So I'm gonna write, oh shit. Okay, so usually when I'm working with promises, I can catch values using catch, all right? The catch function. So I'm gonna use the console.log error and catch the error, all right? Okay, so what happens if I run this code? It's gonna run, we're gonna catch the error, what's gonna happen? Let's try running it. Node.js, we see 100 rejection, all right? So the first thing here we have to notice is the promise constructor. It's not expecting an async function, right? It won't do any await operation behind the scenes, all right? What if we actually catch an error? Error. Oh no. Will this be catch by our error handling here? Let's try out. Well, we can see that, well, it actually didn't catch anything, right? Because I'm not seeing the error log here. So our cat, it's not saying anything, all right? Well, how we properly send errors in a promise? Well, easy. We can actually call the reject function, all right? And now we can see the result. Okay, now we can see that our error handling is working fine. So never actually use async keyword here. It's pointless, right? We are using here promises actually to wrap functions that needs a callback, right? Functions that we're gonna wait for the result in the future. James speaks a lot about we should never mix callbacks with promises. Well, on this, I have a different opinion. If you want to mix callbacks and promises, you are allowed to do it with one condition. If you handle properly errors. I'll give an example of it later. Stay with me, I'll make it worth it.
First, people will do things like make these async functions, right? Which just causes even more promise allocations. When you await an async function, do you know how many promises are created? Just by, if it's just an empty async function that does nothing else, if you await that function, it creates 3 promises every time, no matter what else it's doing.
Are you surprised? I'm also surprised. Every time you use await, it would allocate at least 3 promises. Ugh. Before moving on, if you've watched this video this far and haven't left your like yet, you know, right? And you should also subscribe to this channel so you won't gonna miss all the contents I've been creating here. In case you wanna be notified about all the content I produce, I invite you to join our Telegram channel. I'll publish articles and videos and create polls so you can suggest content there as well. And don't forget to take a look at my website. I've been giving a lot of talks around the world, and I'm sure that you'll find something useful to study there. Ooh. Now going back to the content. In his examples, he used array operations, but I would like to make things more interesting. What happens if we put a lot of concurrent users to access our application during a period of time? Now I'll compare the impact of adding a single async keyword on a function, use the await keyword for a synchronous operation, and using then and cat functions. I noticed the number of promises James mentioned is not an exact value. In my tests, it sometimes allocates only 2 promises, but you're gonna see that for concurrent users, 3 or 2 unnecessary promises would be terrible and would slow down an application. Let's check this out in practice. Oh, let's go. Okay, I'm gonna copy the same command we've been using in the first example, and I will create our third example, okay? I'm gonna use HTTP requests promises.js, okay? And I'm gonna copy this command and use our free here. Okay, and I'm gonna remove all logs that I have here. Perfect. All right, I'm gonna use autocannon. Okay, autocannon is npm packages that help us to run some load testing. So if you don't have it there, you can install with npm global autocannon. Okay, you can use the same version as me, as you won't have any other problem for environment. Okay, nice. So let's first create an HTTP server. Okay, so I'm gonna use require node HTTP, and I'm gonna use create server. Okay, so create server is the function, and then we're gonna need a callback function to handle all requests, right? Okay, after it, I'm gonna listen for an event, and once listening, right? Once it's properly listening, we're gonna say something like running at 3000. Okay. We have here a request and a response object. Okay, and then I'm gonna say just response.end hello. Okay, nice. Okay, let's just try running this code to see if everything is working fine. I will actually split this terminal so I can run some commands here. So I'm gonna run curl localhost 3000. Okay, just saw the hello. If you don't have curl on your machine, you can go to your browser and run the single command. Okay, you can put on your browser and see the same result. All right, with autocannon, we can actually say how long we're gonna be running the load test. I'm gonna say 2 seconds only because I want some short command here, and I'm gonna run it. Okay, So we're gonna see the load test running and we can see all the results. So in just 2 seconds, we did almost 100,000 requests. This is crazy, right? We just have a hello world here, but it's 100,000 requests in just 2 seconds. It's crazy. Okay, so what I want to do here is to monitor our application, okay? So I'm gonna actually spin this application with the tracing events enabled, and I'm gonna run the same command. I will actually copy paste here so you can see later if you want to, okay? And then let's run and let's check it out, the results. So I'm gonna run only for 2 seconds. And you can see that we are collecting so much data that it's generating different functions here, okay? So I'm gonna stop and I'm gonna create a file here. I'm gonna keep only the last one, okay? And I'm gonna use pure no async, okay? So I'm gonna compare those functions and see what's the difference between them. So I'm gonna put it traces, okay? And let's go back to our Chrome and let's load this new file. It's in traces and the first one, almost 100 megabytes. It's a lot of things. I'm gonna use S to decrease the zoom because we can see a lot of things here. Well, first of all, we can see ACP incoming message. This means how many requests we are responding to, right? We are receiving here. So every line we have here is actually an incoming message, okay? Nice. So I'm gonna omit this and let's just check because there are some information here that is not so relevant for us at this point, okay? But let's check some numbers here. For our load test, we could see here, we have just 2 promises, all right? We have maybe 23 callbacks, incoming messages. Let's check our VS Code. Yeah, we have 27,000 requests, right? So it seems it's close to this object. So we are almost getting all the crashes. Why we have just 23,000? Because it generates 3 different files, right? So here we're just grabbing a piece of those objects. But the number I want you to focus is promise, 2 only, all right? So let's try checking what James said on his talk. I'm gonna comment here for now, okay? And we're gonna see the impact of this single function, okay? So I'm gonna create a function here, async, which is a EFA, right? It's a function that's gonna be executed by itself. And let's try out solving the first myth. When you use promises, we are having async or synchronous operations. So I'm gonna use promise.resolve, okay? Like ABC. Okay, and I'm gonna do it 2 times, but I'm gonna wait from this result and I'm gonna move this promise object and I'm gonna do the same thing. Okay, I won't grab the result. However, for every step I have here, I will have that for loop that we had there. Okay, so when I resolve this promise, I will run our for loop. Then I'm gonna run again, and that's it for now. Okay, actually, after running it, I will actually quit this process. I don't need the number because default is 0. Okay, what do we have now? So I will run exactly the same thing. And now we have the tracing here, okay? So first of all, let's break the myth that promises are sync operations. They are actually in this folder and 1. All right. So here you can see that there are no spaces, right? So our promises, we can see here how many promises were created. So we have 7 promises. See, on our code, we actually schedule only 2 promises, right? But we have an async here and we have the global one. Okay. So this blocking function actually broke everything, right? Everything was blocked here and we couldn't receive any other requests during this promise. Okay. Nice. Well, the experiment that I was talking to you, it's a bit different. Let's go back to our server here. Okay, actually, we could do the same thing here. No, let's see in a, because it's like a real world scenario, right? This could happen. What if I have this pure async here, right? Let's go to the Chrome again, open that pure, okay? And let's check it out, how many promises and how many objects we have here, okay? So we have all the ticks going on here. And if you take a look at the async, we have 2 promises only, okay? On our code, we don't have any async operation yet. What if I put just async here? What happens? How many promises is gonna be created after it? Ooh, let's check it out. We could do actually a process.exit to check, to just run once, and we can see this barely, okay? So I'm gonna run it once and see the process, see how many promises were created. So curl localhost 3000, and we have now trace 1, okay? And then let's open again on our file. I'm gonna do this just for one request, and then we can see for the others. All right, so here we can see the async, and we have 3 promises, okay? See, we just have more 1 promises just because I added async here, okay? What if I'm gonna use here just async, okay? And I'm gonna move here. What if I have here like async function called perform, and it's not actually an async function. It was gonna return like ABC, okay? And I will have await perform, okay? How many promises we're gonna have now? This is cool, right? Let's check it out. I will do the same thing with curl. We will have now a new trace function. No? Oh, I'm running without the tracing. Let's see. Tracing and curl. Now I have the new one. Let's go back to the Chrome tracing and check this out. All right. So file size, async, 5 promises already, right? Just for a single request, we have already 5 requests, all right? What if I put this, I will clip this one, okay? And I'm gonna comment it. What if I put this as then without the await? What changes? Save it again. I will actually put here async plus await. Move there. Run the same command and run the same curl. Okay. Nice. Let's open the trace again. Load again. And check this out. File size, async, promises, 5 promises. Oh my God, it's increasing promises. Okay, what if I remove the async from here? Here is just the async plus then. Okay, and then I remove the async from here, and I have then, and I could have catch as well. So I'm gonna do the same example. Curl, we have the new one. Let's open this trace file again. File size, How many promises? 4. See how it's important? Let's check it out with a lot of concurrent users. 4, just, I'll put again the async. I'm gonna keep the await function here. And let's check it out, how this is gonna be. Now, I won't run the process exit anymore, okay? Actually, I could keep them here so you can try it out later, okay? And I will just let the console log. Here, I will remove this one, okay? And then let's run again. But now, I'm gonna run the auto kernel so we can see how concurrent users are running, okay? So concurrently, we just have 3 different files. I'm gonna use just the first one. Let's go to the tracing again. And I'm gonna use just the first one. It's 100 megabytes, okay? How many promises, my friend? How many promises for 24K requests? Can you guess? Ooh. Well, if we see the timeline here, we have the promises here, and we can see a lot. Oh my God, see how big is the scroll? How many promises? All right, 64,000 promises for a hello world example. Well, we know that we can create millions and zillions of promises, but this in like high scale, you can have a lot. And if you're creating promises unnecessarily, you can face slowdown and your project, it's gonna be in trouble, right? Because we are actually, let's try out. Let's try if I can find where our event loop is running. See, this whole thing, it's running in the main thread, right? So if I go down to the end, we can see the JavaScript main thread here, right? So all the promises are being executed in the main thread, right? Even if it's actually fast for these examples, but imagine in large scale with an application with a lot of other features. This could be a problem. All right, so our goal now is trying to reproduce the same problem James was talking to us. I would say the problem he was showing us was mixing callbacks and promises. He was talking, oh, don't do it. But even with only promises, we could face the same problem. Let's check it out. I'll first create here O4 memory lake.js, okay? Nice. Well, I'm gonna grab from files, fs, I'll use node, just a pattern here. Well, first of all, we could use fs promises, okay? And then we can start making. So from promises, I'm gonna use a few methods, and I'm gonna use other methods from fs to try mixing what he was talking about, okay? Perfect. Well, first of all, we should understand how the operating system is trying to open a file and write data to this file, okay? So behind the scenes, he's trying to do something like this. So he actually use maybe fs promises open, okay? I'm gonna create a file here called text.txt, okay, empty file, and I'm gonna create the file name here, okay? It's our text.txt. Okay, I'm gonna try opening this file. This will make them available to write data, okay? But I'm gonna do it recursively. So while true, I'll wait, and then I'm gonna say read plus, okay? What happens if we try doing the same thing? Let's try running the fourth, and oh my God, closing file description. What kind of problem is that? Well, if we try using, I think, let's try with another method from YouTube. I'm gonna try doing this differently because the error message is different. So I'm gonna use async open promise file fs dot open, okay? Dot bind fs. Okay, let's try doing with this promisify function and see if the result is different. Well, the result is a bit different, right? Now we could see too many open files. I don't know if you're a Mac user, but I've seen this problem a lot. This means that the operating system opened the file to be written and then he never closed, okay? So this leads to memory leaks. In production, if you are trying to open a file a lot of times and you forget to close it, you can see this problem. That's why we don't use open in production, right? This open is used behind the scenes. Okay, now I'm gonna just copy here so you understand the problem, okay? Memory leak here because never closes the files and reaches the limit, okay? Perfect. The first thing you understood, okay? The problem is if you are writing a lot of, you're opening files to write, you're gonna have some problem. All right. I'm gonna create another function here to be self-executed because I'm not using ECMAScript modules here. And I'm gonna try doing something similar, okay? So let's try using the async open, okay? So const file descriptor will be our async open with await, exactly the same thing we did here, okay? I'm gonna copy paste. Nice. I'm gonna create a global variable here called let global file descriptor equals 0. Okay, so this global file descriptor would be, actually I could put them in the single line just to show, okay, because I'm gonna try using this variable later just to make sure you understood. Okay, to write a file, what we could do here, we could use actually fs write. We're gonna need the file descriptor, okay, global file descriptor. We're gonna have the data, hello world, and then we're gonna have the callback with the error and the result. Okay, so if I have an error, I can throw error. Okay, otherwise the file was okay. I would add here async to write my file, and then I'm gonna try calling. Actually, I will try closing it, okay? So to make things more interesting, I'm gonna do the same thing for close, okay? Now async close. Okay, close. I'm gonna put an await. See, this could be really messy, okay? So we're gonna close this file descriptor, okay? And then I will put here the leak file descriptor. I'll call just FD, okay? False. All right. Well, once I have it open, I will put it at true, as true, okay? True. And then once it's closed, I'll put it as false. And then I will say it's leaked and leak FD. What if we try running this function? Let's see what happens. So I'm gonna try run. It leaked false. If you try seeing our text, the hello world is there, okay? But what if I try and calling any function that doesn't exist? So like function that does not exist. What happens? Let's run again. We could see a syntax error, okay? But I haven't seen this log yet, okay? Well, let's try putting a global error handling here. Process.on. I will grab the uncaught exception and listen for those events, okay? And I'm gonna do for rejection as well. Okay, so I'm gonna use map, event, and I will assign them all to my process.on events. Okay, so I'm gonna grab the message and I will put just a console log here. The same idea, okay? Is it leaked? And now, is it leaked? Oh my God. So this is a global function. Is it missing a parenthesis here? Okay, I could put the message right there so we could see the whole thing. Well, what's gonna happen, my friend? Let's run out. Ooh, is it leaked? True, okay? And then we see the problem. What does it mean? It means that we could actually write more data and we could see the same problem we see here, okay? Because we don't have properly the value here. Well, I've seen people doing this thing. What if we can put some try cat here? Well, where this error is gonna throw? Is it going to the global one or to our cat? If it's going to the cat function, we're gonna see anything here. So let's see. Oh, our cat was ignored, right? Yes, because it's out of context, right? We have callback here, we have promises, and it's being hard to handle, right? Okay, just to make sure this is a problem, let's create a function here, and I'm gonna call it handle error callback, and I'm gonna receive the error, okay? I will actually move this whole callback here to a function, and then I will show you that example that we could use them together if you want, but you should like properly handle errors, okay? So, all right. So I'm gonna return an async function, okay? Because I want to use async await here. Okay, so once I have an error, so I'm gonna put this here. Okay. Once I have an error, I will receive the error and I'm gonna execute a function. Okay. Nice. However, the process.on is not waiting for executing a function that was returned. So I will actually return this function and I'm gonna execute another. So I'm gonna call it like handle. Okay, and after all, I'm gonna call it handle. All right, oh my God, I'm mixing a lot of stuff here, okay? But let's check it out, Well, I'm gonna keep our console error, okay? And I will put our error message and I will call leaked FG, okay? So if it's leaked, let's see. Well, error we got there, okay? And it's leaked. If it's leaked, it means we can write more data to there, okay? So what if I try doing the same thing for the write function, just to make things easier for us now. Async write, so I could write here async write, okay? Now I'm not using anymore the callbacks, right? Let's see what's happening. But we have the same signature here. So I'm gonna copy and paste. And I will put actually breaking line here. And I'll put any random text here. Eric. Okay. Nice. So this means that I was able to write in a file that wasn't supposed to be opened. Okay, so I'm gonna save it, run it again. I see the console, and if I go there, I can see Eric there. All right, so it was actually open. Okay, but what if I try calling the async close right now on this global file descriptor, and try writing the code again? So again, what will happen? We could see, we have recursively a problem here, right? Okay, so what we could do here, in this case, when you are trying to make a callback and the callback cannot handle a promise. Even if I return a promise here, you can see it cannot handle the promise, okay? But what could I do here? I could actually wrap it in a try catch function, or put just a catch here. Console.log, I caught it. And then if I run this code, you can see that it was actually handled, okay? It's exactly the same thing I was talking for you on this try catch function here. I will just say try catch will never catch those results, okay? So you can know. So what James was talking to us here is we are mixing callbacks and promises here. It's not only hard, but it's almost impossible to detect where is the problem, right? So here I'm saying to you, well, instead of using callbacks, trying like parsing it to promises, but in the last case you want to use callbacks, or in last case you want to mix them all, you could actually use a catch function here. I'll show you just a last example where I actually use it. So I'm gonna write a 5.1 callbacks plus promises. Okay. Well, I'm gonna grab our server. Okay, we just created. I'm gonna copy them all, paste it, remove all unnecessary code. Okay. In this case, when you are working with servers, this means that we can like ping databases, we can wait for other process to finish, and maybe this callback should be async, right? This one, we should wait. We don't need to use then and catch and so on. So what I usually do here, let's try, like I'm gonna import from node timers promises the set timeout, okay? And I will call it maybe async insert data. Async function insert data, okay? And I will simulate some heavy operation on the database, and then I will return just okay. All right? Just to know that we can use promises in callbacks. So now I will actually grab this result, insert data, const result, okay, and use the result here. So if I try running this code, it will actually run, okay? So node 5, and then I'm gonna run that curl localhost 3. Okay, after 1 second, it returned an okay. All right, but what if we have some exception here? What if we have like a promise rejection? Oh no. In this case, we're gonna see that nothing happens. We have our application just broken, okay? And we see the promise rejection error here. All right, so what this means is our create server could never handle a promise. So what I usually do here is I actually wrap it into another function, okay? So would be like our function handler, which is not async, all right? And I'm gonna return this function. However, I'm gonna grab the request and response from here as well. And then if I have any problem, I will see the problem and I will console.log. And then I will response back error. We could actually response dot write head 500, and we can handle the response. So now I'm gonna pass the response handle right here and see I'm handling the error here, okay? So when I will run this code and run our curl, see, I think I have to run first. Let's see. Oops. Okay, let's run first. And after a second, I see error no on our error handling. But if I see here our code, oops, it's I. We could see an internal server error problem. I was handling everything, even that I'm mixing callback functions with async operations. You see, you could do it, but you could do wisely, okay? Well, the last advice is, whenever you can, try parsing callbacks to promises. This will help you a lot to maintain the code, even if it affects a bit on your performance code, okay? Well, I really enjoyed what James said in his talk, don't you? Let me know here in the comment section what you find about this idea I had of analyzing a conference talk and highlighting the best takeaways. I plan to do it more, but I wanna know if you really like it, alright? Promises are powerful and Node.js can handle zillions of them. They are just a notification system to make it easier to handle callbacks, but this can lead to bottlenecks and block the event loop during connections. Make sure you avoid unnecessary allocating promises, otherwise you can end up with bottlenecks in your applications. Make sure a promise will wrap an async function that will be executed in the future and never wrap synchronous functions. It's pointless as they are gonna be executed at the same tick. Avoid mixing callbacks with promises, but if you do, make sure you handle errors properly. In James' words, promises are both powerful abstractions and exceeding easy to do incorrectly. Understanding how JavaScript and Node.js schedule system works is key to understanding application performance. Please tell me here in the comment section what ideas or questions just came out to your mind. Ufa, I hope you found this class useful, and don't forget to check the content in English playlist here in the channel. I've been building a lot of new content and I'm sure you're gonna like it. Comment below what you wanna see in the next videos, and please send this video to all your people at your work, your friends, and your study groups that I'm sure it can inspire them as well. I hope this content has exceeded your expectations. Subscribe to this channel and enable the notifications so you can be notified about all the new content I publish here. I'm Erick Wendel, and I will see you in the next video. He brought examples from the real world. As you're used to seeing this, and as you during the questions and answers sessions, I was like, oh, that talk where James says showing practical examples and adding some complements, and adding some complements. And in the Node.js channel, and there, I actually picked some specific videos talks. The top most interesting subjects there. Oh, filha da p***. Calma, não, agora, velho. I suggest you put it into our. I suggest you to put it in our. There are going back to the talk. James shows us going back to the talk. Might want access what? Cara, essa notificação enche o saco, velho. I plan to do it more often, but I wanna know if I plan to do it more often, but I really like it. I plan to do it more often, but I wanna know. I plan doing it, but